Okay, sorry for being late. The usual Windows audio trouble stuff, and I forgot to turn on my chat, so just ignore me for a second. I hope this is not gonna... This is the wrong keyboard. That's what you get. Yeah, it's been a while, so all the routines are... Come on, Windows, don't act like you're stupid, even if you are. Thank you for autocompleting. No, I don't want to reboot Windows now. Just give me a second. Give me 5, 10, 8, 29 seconds. Okay, this is better now. So if you send me messages, I can see what you're doing. So actually, let's switch here. Well, Cheval is still running, and maybe this is... yeah. So Cheval is still running, and that means we still have our nice green, red, white, blue screen, and I actually fixed the keyer, so it's keying on the right green now. So you see upper corner is nice and transparent. Still ignore that cursor is there. It's going to be fine. So that's where we left off last time. I'm going to turn this off because this is too much of an overlay, and yeah, basically remember the DD, and now it's all black, and if I run this tool, it will show our stuff, and obviously this is not what we came here for, right? So this is not what we came here for. The goal is still have this generic stream overlay, and yes, I am overlaying myself over the overlay now, but that's gonna go in the near future. So I want to stream without the second laptop, basically, and maybe create a smart mirror tool while doing that. So that's where we left off, and actually, remember we had this nice, to avoid the Raspberry Pi in the mix, we have this nice version where we can... oh, little me, mini me, where we can test locally. So that's where we left off. It's all here in the usual place. So what we want to do today, I mean, it's nice that we render this frame thingy here, but we want basically different things to be rendered on screen. So excuse me, drinking the bubbly water too fast. So basically, we want to render something useful here. I mean, simple as that. And how do we do this? Obviously, there's also all the cleanups we still have to do. So, but we want to render stuff, and stuff is a bad name. So we want to render thingies. Yeah, no, let's not render thingies. Let's render... I'm wondering... well, whatevs, it's dummy code. So let's render elements. So what I actually want is touch source, let's call it element. Windows. I worked in Windows all day long, so nope, I don't want to save this. So what I want here is have a list of elements that I can just render, and maybe I want to pass some data through, or maybe have a real closure here. I'm not sure yet, but basically we want to render elements, right? So, okay, let's go to the lib and say, yeah, we can remove all the unit testing code and say we want to render the elements. And then let's do this rusty. So we want various elements, so we define a trait that we'll use during the rendering, and then you can implement whatever you want. And so what I want is an update that gets a mutable self. So that's called once per frame and just updates whatever needs updating. Then we have a draw. Let's call it render, actually. So then we have a render, and that gets a non-mutable self. I need my data, obviously. And then basically we use this signature, right? I mean, basically it's the same. So I could pass every element its own buffer and then split these buffers together, but I want the elements to be smart. So we could have filter elements or overlay elements, and elements need to do the right thing. It's a basic gist of it. And basically that's it. So usually I would also add a function new to create these, but this time I want to have basically blah. I want to put different types of elements that all have this trait but could be different types into the same bucket, so they cannot have a new. So I'll just create a configure. We have something that creates this, and then we configure them, right? So this is our basic interface, and this will be bigger. So looking back at our green screen here, what I want to do is I want to do this with 4 elements, just as a start, and see where this goes. So what I'm going to do, and long term, these elements, let me just keep my naming right. Long term, these elements won't live in the base. They will be a library that's loaded dynamically, but for now, and just to make sure we don't forget them, we add these 2. So right here, we add the block element. And actually, let's open that here. So this is basically a struct block element, and then we have an implementation for block element, and here it gets interesting. No semicolons. Here it gets interesting. It's an element, so also we want to implement element for block element, right? So if we go here, and now it gets a bit ugly because this is 2 scopes, but basically let's say we have a mutable element, and that's just a vec new. Don't ask me what I'm doing here. Oh, we have to pass in the elements, right? Yeah, C++. I'm writing C++ code. Let's not do this. Sorry about that. So basically, We'll need some structure here, but for now, this is when you, so this is our struct and an implementation for Cheval. And then this render frame basically gets the function, and so this is a window code. So let's do the initialization after the window, because so let mutable Cheval equals Cheval new, and then obviously this needs a pop fn new. And I switched to using self here because that makes renaming stuff easier. And then we can put our elements, elements. Oh man, long day. So just empty, right? And then we have a pop function at element. Probably we will make this a bit different, but let's assume we can add elements from the outside. So we need immutables. Don't you love the tab 9 autocompletion here? And this is basically just self elements push element. Wow. And then render frame obviously gets the function and the user defined data pointer. I will just cheat and just pass Cheval in here. The reason why. Okay. Let's start to clean this up, because we're getting into trouble because we're not clean. So all over the place today, but basically, okay, let's copy all of this in here minus the actual stuff we just created. In Cheval, we keep just that. And then obviously the cargo toml, we have to change this to Cheval main and beat me up with a stick, big stick for. Okay, that's our actual block element where we stopped. So we have to use Cheval element. We just get the trait into scope. I saw it. Okay, so let's not do this for the moment. One step after the other. Switching between these two keyboards, they're very similar, but they're like off by a fraction of an inch, and render frame wants to yes, we know. So what we're gonna do here, we're gonna use create element. No, we're gonna use create. Whoever came up with this stupid name. Obviously here we have to tell it the lib basically yes, we want to load this. here we use it, and here we say the render frame. This should be opaque, but I don't want to go there yet. So this should be like void user data. And the render frame just gets a reference. And then this function just gets it passed through. This will fail in so many places. Wait, what? I expected so many failed places. This was not one of them. Okay, we copied out the code, but use create element. That should fix. Okay, so how do we do this? So basically what we could do okay. So we cannot do this because we need to box this. And boxing this is probably not enough. So when we create it, this is blindingly bright today. I'm not sure what's wrong with me. So basically we want to box this at this point, right? Probably. Okay, so we don't box it here. We just get a boxed element. And because I know what's coming, I just make this dynamic. I'm still struggling a bit with the way overloading kind of works in Rust. So this is never called, which is fine. I just want to make it compiled. So the function we just gave it for parameters. That is right, because basically here we say this also gets a cheval reference, so that will fix this problem and move it down one level. And in cheval main, we are not using use create. And we're very close. Oh, wait. Create mod cheval. What am I missing? This one is. This is in the crate, right? What am I missing? this thing is the main is in the binary, and this is in the crate. So we can use crate here because it's technically a binary and the library in two places in the same place. So yes, that means we need to make this public. And then the same in source window minifb. We should really. This is prototyping, so and now the struct is private because we're outside of the okay, and now it says, okay, it expects a function that takes 4 arguments, and we know what that is. That is our main here that just has a cheval. This is basically this. This is us. Too much boilerplate today. And somewhere, yeah, obviously I have to borrow here. So basically, we didn't do anything. Well, we have this element vector that currently has no elements. So what I want to do is, so if I go here, we said we don't want the new in here, but that means we need a factory. Let's put the factory at the bottom. So we have a block. That key again. So we have a block element factory. And we have an implementation of a, maybe we want an element factory trait at some point, but let's not overcomplicate it. Right now, put elements into a list and render them. And this basically has a create function. And that returns a block element. And we cannot use self here, so basically we say, okay, this is basically our new, which cannot live inside the trait, because as soon as we have a new in here, we cannot put the din in the box in the vector, and that would defeat the purpose. I'm not explaining that very well today, do I? No, I don't. Sorry about that, but let's see. Warm-up phase, 4 weeks. So actually what I want to do, tell you what, let's give this thing a name. Do I want a name? Do I want a name getter? Yes. Just so we have something to, so basically we have a name string here, and then let's say block element has a pop function set name. Wow. Str. And that is basically self.name equals name to string. String handling is still a bit weird, and here we have to say name non to string, right? Moving too fast, I know. But what I can do now is I can say, okay, let block element equal block element factory create. And this is unparameterized, so I can have the block loading itself, which is nice, but this means I might need to make it mutable. And then I basically say block element set name equals, I don't know, looking at this, let's call it the green block. Actually, let's call it block element because I'm lazy and I might want to reuse this. And then I say cheval add element and give it a box new. And here's the place where we put it into the box. Right? And obviously we have to use cheval block element star. Okay, fair enough. So go to the lib, make this block element public. Use of undeclared. Okay, let's be very explicit here. The element and its matching factory. This is gonna be, wait, oh, it's private? It's private. My bad, it's private. Okay, it's saying the trait is not implemented, so at the place where we want to add it to the add element expects it's something that has a trait element, and yeah, we commented that out. So to actually implement the trait, and let's make this easy on ourselves. Oh, I'm keeping hitting the wrong buttons today. And basically, we just do nothing. Well, this returns the name, and here it's where I would like a bit more of inheritance, so we have to copy this everywhere. But basically, what we can do now is okay. My permissions are a bit tight today. Oh, it's a method, it's not a field. Yes, so set name. But now, okay. So if we just go here and use the debug macro and macro and debug what we have so far. Okay, Cheval doesn't implement debug. That is right. So let's derive debug. And it's probably going to be the same for the element. Oh, element doesn't implement standard format debug. Now this is going to be a bit more ugly. The problem is, so element would, we could just say, okay, derive debug here. But the problem is we cannot derive debug on traits. But what we can do, I hope, we can implement standard format debug for element, which is a bit meaningless. I mean, now we have to implement format, so we have the missing format implementation. So function format self mute standard format formatter, and it returns a standard format result. And basically, just for debugging, we do a write line into the formatter we just get passed here and say it's an element, it's trait. Not sure about the formatting here, but trait element, and we know we have a name, so we can just say self.name getter. Yeah, my braces got a bit mangled due to the auto formatting. And that's it. Oh, no semicolon. Sorry about that. Well, actually, let's explicitly return f here. No? Oh, wait, no. My bad. Let's do it like this for now. Value borrowed after move. Oh. Too easy, right? It's mixing programming languages. So if I run this now, I still get the same stuff, but I have this list of elements now, and the first one is a green block. And just to prove that it's working, so what we're gonna do is we're just gonna copy this green block and say this is the red block. And now we're getting somewhere. So we have this list of elements now, and what we can do now is in the render loop. So instead of rendering this, well, let's still render this and say for e in cheval.elements. Maybe cheval render frame should be a method on cheval. Maybe all I want here is a pop fn render. And yes, the abstractions, I think I have one layer too many. Wasn't that just the perfect auto-completion? This is our render code, right? And then here we just say cheval.render buffer width height, and that's it. And then here we copy this here. And obviously we're inside us now, so that's better encapsulation. And hey, Strawberry Hacker, 48, yeah. Thanks for that, on a day where I'm totally off my game. Obviously, we need a mutable self-reference here. And then we should be good too. Hey, any of you Rust programmers? Any of you can help me with struggling through this stuff I'm doing here? Oh, come on. Come on, was it really? Yes, it was usize here, and it's U32 here. Classic. Classic. Obviously, render doesn't want a mutable here. We don't need it. So we still have our blocks, but we call the render loop now. So how can I prove that we're actually doing that? Oh, we can just debug debug e.e here. That will be a bit spammy, but so we're rendering the green and the red block every frame, which is nice. Which is super nice. So goal is still kind of this, which is overlay for the stream based on a Raspberry Pi, and we're getting there slowly. So render is called, and remember, elements have a render trait, so have a render method. So we could say e.render. Actually, yeah. I mean, this will do nothing yet, I guess. So nothing to see, but what we could do is let's steal this ugly code from the main and just say whenever we render a block element in the empty render here, we just fill the screen with. Actually, I could have copied a little bit more here. Pick a color. Okay, there's only one color to test, which is our lovely magenta, which does not exist. So let's see if it still compiles. And what do we expect now? Whole screen is purple. Sounds trivial, but we just laid the groundworks of being able to dynamically configure these panels. And just to, let's just try, this probably will break, but let's build the ARM version, and obviously we forgot to change the signature. So if we have the minifb here and the framebuffer here, the render frame signature changed, remember? And if that changes, we probably should do that here too. So basically this, and then we just pass that through, right? Oops, what did I? And then we had to do some imports. Use, not import. Wrong language. Wrong language. And just to prove that that's still working, so switching to the Pi, empty screen apart from the cursor, running the old version, green, red, white, blue, and now I SCP over the new version, run that, and it's all magenta. Exactly what we were looking for. So we're slowly getting there. So how can we make this more interesting? I mean, the thing is, we can remove this now. This was our dummy background code. But we can also let it there. I mean, right now we render two blocks, the green block and the red block. And maybe make them green and red. So here comes the tricky part, since at this point we're using the trait. If we go to the block element, I mean, what we could say, we have a color, which is a use32, and here we just use the color, right? That would obviously self.color. That would work, and then the initialization, let's say, let's use something we haven't used. And we switch back to local testing because that's just faster. So now we can set the color in the object, which is still kind of, I mean, what I really want is, actually I want the X position, which is a use32. I want a Y position, this is a use32. I want a width, and I want a height, right? And let's default all of those to 0. And actually, I think the configure part is gonna be interesting, because what we actually want is, I want something flexible, aka semi. And what I actually want to do is, I want a way to tell this block element here, block element configure, and in the end this will come from a configuration file like YAML or JSON, or not sure yet, probably YAML, because we want this foolproof and readable. So config block config, right? So what I want is let mutable block config. No, it's not block config, it's element config equals element config. Thanks for the autocompletion, that was amazing. So I want to do something like this, and then I want to say element config set use32, and probably I want something like color, and then put in, I don't know, let's put in some kind of gray. Right, this would be nice, because this way I could just say, hey, I handle all the config values for you, but I don't care what they actually are. So this would be nice. And I'm leaning towards just slapping the element config here, because it's needed. So basically we say element, we just say config here. In this context it's clear, it's an element config. And we borrow that, right? So what we need is a pub struct element config, and an implementation for the element config, and basically, so what do we do when we say, okay, we have a pub new? I mean, the new is easy. The new is just boilerplate. New is just boilerplate, but the pubs function set use32 to mutable self name. Right? What do we do here? So basically we want to have entries, and then some kind of hash map of string to the use32, nice if all our configuration is U32, so we can just do that, but this shouts enum to me. So pop enum element config entry. And for now, we just have U32, that's U32, right? And then we can extend it. For now, we just do the U32, and here we just say element config entry. Right, so entries is hash map new, and yes, used collections hash map. And all we have to do is here. I'm wondering if we want to do a default, so I'm gonna call this add instead of set. Set is fine. I'm just wondering, this stuff is supposed to come from a config file, so I'm wondering if we should always add strings or string slices. But basically self entries insert name value name element config entry u32 right? This not u32 value, and this probably needs a toString because it ends up in the map as a string here. Okay. And then this needs to be U32. So now we can slap every U32 in this config thing, and then the configure of the block element, here, this one here, we just changed the signature to this. So the configure of the block element, this one here can just say, this is shaping up nicely. This is going somewhere. This is going somewhere. Obviously, we still need a getter. I mean, basically what we want to do is here, we want to say self color equals config dot get u32. I like the auto completion. The name is color. What do we do if this value is not there? Who handles that? Do we get an option to u32? I will just cheat here. Well, I'm not even sure if it's cheating, and so our element here, our element config needs a pub get u32 or default. So if it's not found, it will return the default. So right now we could just say default. But basically we can do match braces self that entries get name. Does this need a toString? Probably not. And then we say if it is sum, And we can actually check if it's a U32 value, then we copy the value. In all other cases, we just return the default, right? Straightforward. Oh, what did I mess up? Maybe this should return something. Maybe. So we should have a gray block now, which is overdrawn by the other block. So let me remove the red block here for the moment. I mean, this is gonna be here soon. Block element configure method not found. Wait, what? Didn't we just... Oh. No? Oh, it comes from the trait. So yeah. What's wrong here? Method not found in block element. We need to bring the scope in, the trait into scope. Wait, the crate. Oh, not here. Here. We use this is a trait method, so okay. Fair enough. Well, let's... Obviously, element is private in the lib, which is fine. I mean, start with minimum. Okay, and obviously we are lacking a borrow here. But now, okay. So, gray box. Gray box, all configurable from here, from the config, from outside of the thing, which is what we wanted, right? Green box, nice. So, we could do the same for... How do we do this? Let's see. Let's say we set x to 0, and width to I don't know, it's 320. And then here we say for x, we render for x in 0 to self.width. So we don't render the full window, we render the box width. And this probably is gonna tell us as hue size. So basically I expect the gray box, the gray greenish block, to be half width now. Which did not... Where did we... Oh. Yeah. maybe we need to, in the configure, also say, okay, x is x, and I fix the formatting in a second. So x is 0. Actually, let's copy this y width height, and actually let's put it in order of the initialization. Yeah, we could just set the name via config value as well. Height and width, and just because I am like that, this should increase readability a bit. So now we actually read the value setter in the config block and default for default height. Maybe you should set the height to whatever the window buffer height is here, 360. I just want full height here. Even if it's not used yet, but look, half a green block. Half a green block, and if I do the build for ARM now, copy that over and start this. Obviously this is full HD now, so all our sizes are off, but I don't care about layouting right now. So you see our nice green bar on the side, and this is getting somewhere. This is getting somewhere. So I'm wondering, let's fix the blocks. Step 1, fix the blocks. So I actually want this to be the, so this is our greenish block. And then just here we make a reddish block, but we put that into the lower right half, and we want to make it reddish. Probably it's gonna turn out pinkish, but something does not look right here. Yeah. So obviously it's ignoring the offset, because in the block renderer, I mean this is just sampled, so basically we do self.x plus. So this is the x, highly unoptimized. So we have the green block on the left and the red block on the right. Obviously the same for the y, so we do room for optimization here. Really. Probably we can just put the SU size on the very outside here. Width. Yeah, it's and then obviously here it's y plus self dot y. I'm not sure why I didn't hit the plus key here. I mean, this is such a horrible pixel fill loop, I don't even want to look at it, but what did we do here? So y times width. We need to do some clipping here. I mean, let's just cheat and add a little border here. That's one you do quick hacks. So line 68, 34, 22. Cheval line 22 is the call to the render. Yep, that's here. Element line 32 is actually, yeah. So what is our what is the actual problem? Do you see it? Do you see it? I don't. Okay, our index is too high. Height is height. I mean, obviously, okay, let x equal x plus self.x. If x larger or equals self.width, continue. Right? And then the same for, yeah, let's change the name of the variable to position x just to be extra sure. We could do that, but we want to keep it readable, right? And if the position y is out of height, we just skip. That's basically clipping on the lower right corner, right? And then here that is py, and this is px. Something is dodgy with our pink block. Oh, wait. Something is... I'm just not gonna add the green block, so we only have the pink block. And then I'm gonna debug px, py here. This will be slow as hell. Wait, what? I mean, the clipping is working. Self cannot be, doesn't imply, okay. I hope this works. It's looking good. So let's ignore the color. Oh, the Y is 320. Why is the Y 320? Did I? Oh, my bad. My bad. Still no pink. x320, width 320. Where is it? Okay, step 1. Let's set this on the, so we should have left half, right half again. What if we set this to just 20? Where did I make the boo-boo? Okay, it stops at... Wait a second. Okay, it stops at half the screen. Why? Self.width is 320. And the starting position is 120 though, so this... Oh! Maybe we should clip at the window and not ourselves. Yeah, to be decided. Okay, now we have the X stuff is working. And we re-enable the green stuff. So we have the light green and the light pink now. And just for fun, wait, what was it? Light green, light pink, white, and blue. So let's just add these 4 blocks. Actually, I'm lazy. So this is the white block and this is the blue block. So let's make the white block kind of grayish and the blue block kind of bluish, and shift that to 180. And you're seeing this is why I want this in a config file. So we have our 4 blocks now. We can run this on the Raspberry. We can run this on the Raspberry, but it will be totally wrong. So the big stuff is our background test code, and the upper stuff is our actual elements that are being rendered. So, and the keying still works. I mean, the semi-green is not what we wanted, but I mean, this is so useful, right? Something you need every day, colored blocks on your screen. Good one, I know. Very, very good one, I know. So, but what I want to do is cleanup to be done. Add elements. Add elements. Add block element. Add test config. Oh, test config via code, right? I'm the only one pushing, so no need to fetch. So here's the thing. I don't want this, right? I want something like touch example config dot let's go with YAML. So what I want is, I want somewhere in the config, I want elements, and every element has a name, right? So in this case, it's a red block this here. And we support multiple types of blocks, which is ignored for now, but say the type elements, so the type is block. And then parameters. So here comes the kicker. We could say x equals 0 and y equals 0. And then you see the highlighting here. A single y has to be quoted in YAML. So I'm probably going to call this position x and position y. And then we have a width. Oh, this lines up nicely. So we're still here. That's 320. And a height of 180, right? And basically, for now, oh, we need the color. Now it gets interesting. So color. Let's do strings now and see what we can do there. Basically, that's my red block, and as I said, the config of Smart Mirror Magic Mirror drove me so crazy that I wanted something simple, and I believe red block. Wait, that was the green block. So this is a green block. The red block is the one that's for now offset. Maybe this should be relative, but maybe the screen is always the fixed size, and we just use the fake red color here. I think this is readable. I mean, everybody can see and edit this without a big chance of breaking it, and I think that's the main thing I want from this. So how do we parse this? I mean, in the end, right here, instead of this, and let's remove all of this and just do a quick check that it's running. I mean, no elements, nothing to render, we just get the dummy background, fine. Maybe we should remove the dummy background at one point, but let's just, okay, cheval load, and then we just say example config.yaml, right? And then we have a pub function load, which gets a mutable self because we're changing ourselves, and then the config file name str. Maybe this should return a result, but for now, if we return a result, we can unwrap in there. So I'm gonna return a result. Nothing in both cases. Probably this should be a. Do we want to go there? Standard error. Yeah, I wanted element. Foo you. And we just return an okay here. Okay here, right? Oh man. Right, so cargo check. check, 1, 2. Wait, what? Oh. Okay, and since the size of standard error is not known at compile time, maybe it's time to go for standard anyhow or something. So the trick here is we can box a dynamic here, right? We just box the D in here and don't care anymore. Nice. So, but what we really want here is we want to okay, let's cf for config file is standard file system file open config file, and we should be able to just unwrap that here. Nice. So if you have a typo, it will just throw up, and here it will fail, but we don't care at the moment. And then let's actually I'm pretty sure that crates.io Serde, oh, let's just use for SAML. Serde serializer deserializer has YAML support, so let's put this in the dependencies. And then basically, okay, we can derive serialize, deserialize for some stuff, and then basically can load that from a file, which is nice. So yeah, I'm not gonna write a I'm not gonna write a YAML deserializer manually. So, but so yeah, and that was the wrong file. Ba-bam, ba-bam. So what I need is a struct config. Right? Let's put this here. So a config, right now it has more, but it has elements, and that is a vector of something. Well, that's actually a vector of config element. I mean, pure naming dictates that we have a struct config element, which is a single element in that config, and that has a name. I mean, we have the config here, so we and if I name this type, so let's name this the type and annotate it later. And then we have the parameters, and that's hash map from string to string, right? We could go overboard here, but this is basically as we don't care. This is our opaque string mapping thing that we don't want to get into. So basically, can I write struct, please? And all we have to do now is, okay, we derive it. We derive debug, because debug is always good, and we want deserialize. The same for this, and then obviously used collections hash map. Why can't I derive deserialize? What? Oh, use the YAML for the YAML support, obviously, but the more important part is use the derive deserialize. No? What did we forget? Oh, yeah. We didn't pull in the module yet, so... Wait, what? Oh, obviously we need to enable the derive feature. Do we? Hey Raising, thanks for the follow. Obviously, if we want derive functionality, we should... Yeah, and now it's pulling the code, which we forgot, so... Compiling Rust is still very, very slow. It's gotten much better, but it's still... But I think it's Clang that's actually the base problem there. So, unresolved import the derive. Is it not? What am I missing? Oh, did they change the interface? Oh, the interface changed. It used to be Server derive, and now it's the feature derive. So fine with me. So basically, what we can do now, very, very straightforward. In theory, we can say let config, and we have to tell it the config, and then we just go server YAML from reader, and we unwrap that. And what we can just do is debug the config here just to see if this is working at all. Oh, our annotations are still broken. Yeah, true. So it didn't find any element cause it looked for the type here. And I just happen to know that you can say serde, is it rename? Oh, the auto-completion for the win. So we rename the type, I believe. Probably. Let's try. Let's try that. So here are our config elements. Config element, green block, parameters, config element, red block, parameters. So literally we told it how the format looks like and told it, hey, can we please have that config? Obviously now we have to do something with that. But what we can do is, okay, for C and no, actually E in config.elements, So basically for this and for every dash here, for every dash. And now we go back to our main here, because basically, let's ignore the block type for the moment. So let's do this. We always create block elements. And the name is actually the e.name, right? Yes, I know. Bring that stuff into scope. Now, in this case, it's crate. Wait. Wait, what? Oh man, what did we... What did I miss? Didn't I just have create colon block element here? I mean, that's literally what I wrote, right? Oh, yeah. That's literally what I... Okay, and then we borrow the name. And in the main, do we still have the debug? Yes, we have the debug. So we should have two blocks with just names and no... Oh, wait, we still have to say self.add element, block element. Oh, sorry. Box new, obviously, for the mentioned reasons. I wonder if the factory should just create the boxes, but so if we run this now, I still think we have the debug in here, which we don't want. So we have the config file, which has a green and red block, and we have the elements with the green and red block. It's still not rendering because we're kind of chickened out halfway, but that's simple because the config here. So I mean, basically what we need is we need an element config, right? We need an element config. So the thing is, what I really want to do is for p in e.parameters. So basically for everything of this, I want to say element config dot set. And basically I want to say p.0 and p.1. Obviously I borrow them. So I don't care if it's US32 string picture of your best friend, and then let's just wrap this up, and then we just say basically block element configure. So this setter obviously is still missing, but basically this is load the config file, take every parameter and set this in this map. So if we go here, it's always the wrong side, isn't it? So what we need is a set. So we need a generic set that has a mutable self, has a name, and has a value. And now comes the magic. So I mean, we could just set everything as string. We could just set everything as string. I mean, Rust value parse. We could just try parsing. We could just parse every. Hey, security, how's it going? So basically, what we could do here is have a big. I'm not sure I want to go there. So what we could do is if let okay. If we get a value when we try to parse the value as U32, if that works, then basically we add it as a U32, right? If that works, we just put the V in as a U32. What the, oh. Wasn't the syntax, oh, if I do a value parse, wait, that's, oh, yeah, sometimes it's good to read the arrows. This is I don't want the method, I want the call the method. So if this works, we use it as a U32. Else we just say, okay, we tried our best to parse it, but we don't know what to do, so oh, we tried our best, but let's just put it in as a, do we want this? Probably. So it's not a U32, so just put it in as a, and in this case we just take the value and obviously the classic toString. Right? And we can extend that, we can be smart. Oh, is it a color name? Then make it something different. I mean, this will probably kill our colors right now. I wonder. Let's just compile this. Step one. Let's compile this. Let's run this. It's actually not too bad. I mean, here's the red block. The type is block. No, wait. Oh, we really want this to dump out, right? So obviously our colors don't work and our positions also don't work. Why? Actually, what I want to do here is debug our element config. No? Come on. Oh, okay. Fair enough. Element config does not implement. Sometimes the auto completion breaks, and then yeah. That's easy to fix. I think by default everything should be debuggable. Okay, so we have a width and a pos and a height, and the color is broken. The height is 180, the width is 320, the pos y is 0 in both cases, and in one case it's 0, and in the other case it's 320. But shouldn't that then be... I am confused, so I'm gonna push this down by 180 and see what happens. The colors don't work because we know the colors don't work. What I'm wondering is why the second block doesn't work. I mean, we're adding 2 blocks with 2 configurations, right? And we have the green block and the red block, so... Shall we fix the color for... I mean, obviously we could just put a... Can I do... Yeah. We could just put a 0 in here, right? And then the green block would become the black block because now it understands the color is black. So it's a second block that's actually not rendering. So it's black now, and I could just put I don't even know, probably too high. But who wants to enter the color in decimal? Yeah, so let's fix these. The color was actually quite nice that I hit there randomly. So what we actually want to allow is here. Okay, you cannot parse it as a U32, but maybe we can. So what we can do here, else, I'm gonna go if, basically same pattern, if let okay v equals strip prefix. So if it starts with OX, do something, and this is just our old else case, right? I'm not sure if this should be our... I'm considering doing this, but let's see. So if it starts with an OX, and I can do a U32 from string radix. Sometimes the autocompletion just saves you value 16. So match, and this is where it starts to get ugly. Yes, okay, thank you. If we have some value here, then we have a U32, right? And then we just do this. I'm pretty sure this thing can be cleaned up. Why are you complaining here? Because it's a match arm, yeah. And in any other case, just do this, and then that's why I don't like it this way, because the default is duplicated. And we may have the same thing here and here. Oh, it's not an... Fine. Had it the wrong way around. And obviously here we need the stripped version. We could probably fold that into one, but let's... Not too bad. I mean, we still only see one of the boxes, so height 180, pause width. Height 180, pause width. Oh, it's pause X, while our block element actually expected pause X and Y. Alright, so green and pink. And now adding the white ones becomes an exercise in taking this file, I just cheat and want to copy the values, so let's just copy both blocks. And now the fun starts slowly, admittedly. So this is the white block. It's left, but it's down, and this is a blue block. It's left, but it's down, and the colors are this one for the white, but it's not technically white, and this one for the blue block. And suddenly we have the green, the red, the white, and the blue, all from a config file. Obviously, if I build this for the target now, it will be a while. It will be a while. And then I SCP this, and obviously what I should do is also copy the example config over. No config, no output. Dot YAML, I guess, yep. So if I go to the Pi now, which still has the hard-coded stuff, which is a bit bad because now we can't see, but you can see it's loading the config just the same. If I go here, I see this, and now I can just edit the config and say, okay, let the green block start at position 30. Right, so if I run this now and go here, you see it's offset. It still has a fake green behind, but actually, if I key this over, this is getting closer and closer to what we actually want. I am still not sure about the... I'm not sure about the... I mean, the thing is... Okay. We added config loading, so all this hard-coded crap is gone, which is nice. We only have the block element, and we don't have anything dynamic yet, so we don't even call the update. So not called. Not called at all, so yeah. Maybe we should call it. So Cheval has a render which is called from the main here, kind of indirect. I'm tempted to just say, okay, let's remove this and just let's don't kill me. This is not the best way to clear the screen. This is not the best way to clear the screen to black. And just to prove that that this is actually true, that it's cleared to black, it's cleared to black. Before I destroy this much further, I need to refill my water soon. And by refill, I mean exactly what you think I mean. Git commit -am load config from YAML. As always, it's all in this repository here. Well, it will be in like 15 seconds, so all the commits are here. Just for you to follow along, it's public, so just feel free to clone it. I need a super tiny bio break, and I will be right back. No, let's not do that. So, see you in a minute. Whew. Nice progress. So, we will develop this whole thing on the stream, and it might look like nothing right now, but trust me, we'll get somewhere fast. He said and lost train of thought. So, where were we? We had that panic in the update, obviously, which at least I want to trigger. So yeah, probably. Yeah, this is how we gonna do it. So we will add a pop function update. Didn't it just say mutable self? Right, and in there it will just say for elements e.update, end of story, end of foo you. Woo-hoo. And then here we say cheval.update. And get out of the way, noob. It's not your first rodeo. Oh. So now I expect a panic. And it panicked at not called, so I mean, but how do you update simple blocks? Tell you what, let's make something fun. Let's make a new element. Touch source. I take requests. Starfield. Nice. Moving dot. Moving dot. Moving dot is a good idea. Lisa use element.rs. Yeah. But we do this in 2 steps. So we take the block element, and then we just, I mean, basically, Lisa use. Basically, that's how I expect people to develop new add-ons. Just copy an existing one and then tweak it. And basically, that's step 1. Then we need to add it here. This is just a plain copy. So, okay, maybe this here needs changing to. So, step 1, copy it. Obviously, we have our example config here, and instead of the green block, I want a Lisa use. You still don't know what that is, doesn't matter, Google it, but we're getting there. So, right now, we will still see a green block if we run this, right? So if I do cargo run, still see the green block, and you say, wait. You're a cheater. You are a cheater, and I tell you why. So I'm actually gonna extend this, and this has a name, and it has a type. Might not be a smart idea, but yeah, get, let's say, element type. Element type might have been a good one. And then the block element says, okay, if you ask me for the element type, I'm gonna tell you I'm a block. Just to have the differences. And the Lisa U element for the element type is gonna tell you I am a Lisa use. Didn't you just... Sometimes the autocompletion just... Okay, doesn't really help, but we have an element here, the writer, And we just gonna put the type here. So self.element type. Whatever. So if I run this now, you see it's all blocks. Even if our config says, where's our config? Even if a config says, hey, wait. So yeah, maybe we need to tell the loader, because here whatever we do a block, right? And that's not what we actually want to do. So let's change this to element. And actually, let's say let mutable element. We box it up here. And there's a reason I do it in 2 steps. So we box it up here. That means we don't have to box it anymore down here. But that means from here on we can make it generic. So still same behavior, still it's a block, which we don't want. But what we could do is here, okay, here we say instead of block factory create, and we will create some magic around that, but for now we just say match conf e dot the type, and the type is a string, so we match block. No, actually we match it the other way around, so we do an as ref here and then say block. If it is a block, we do this. We call the block factory create. Any other case, we just panic. Unsupported element type e the type, right? And no semicolon here, but one here. So this is if it's block, just create a block. If it's anything else, just panic. And it just panicked. Unsupported element type Lisaju. And actually, I'm not sure if I want to panic or if I just want to say, okay, if we don't know what it is, we just continue. We just continue. This way, at least we see the other stuff. If we misconfigure one of the elements, I prefer that. Should probably throw an error. Actually, let's do that. Print line, print. Whoa. Unsupported element type, e the type. Actually, let's say skipping unsupported element type. So we get a bit of, I mean, it's in the debug noise right now, but basically skipping unsupported element type Lisaju. But you don't want to skip it. I mean, Lisaj, who came up with that name? Probably the guy who invented it. I used to say Lasajis, and then somebody told me, no, it's not Lasajis, it's Lisaju. So basically, and obviously we have to type my favorite name again. And because I'm too lazy to type it, probably we don't even need the Yeah, okay. Let's clean this up, because we don't need the specific type anymore, because we have the trait and they all behave the same. That's why we went through this boxing. Oh, obviously we have to box it here now, because otherwise hmm? Oh, can't I? Do I have to say this is a box of a Dune element? Yes, I do. But then I can't set the name anymore. Oh wait, we can, well, wait. We can just say function set name mutable self name str. Right, and then we go to the block element and actually move the set name from here to here. Yeah, that's why I don't like this inherent and here it's just boilerplate same, and this is gonna go cargo check, obviously. What? What? What did I mess up now? Oh, we double boxed it. We double boxed it. So we have the green block, which is Alyssa U now, and the red block, and the white block, and the blue block, and all dynamic. Thanks for the bot. Just ignore. Yeah, my font in my chat is like 2 pixels. I think we're reaching the 2-hour mark, and we said 1 hour 30. So I'll just gonna do the. Okay, let's just do the absolute minimum, because here in the render, let's actually do this, and then we say okay. Okay, what do we need? We want something time dependent, right? So we have a TF32, and maybe the update should pass in the time delta. Basically, I want something that on render. Okay, let's say x equals. Let's say x equals. Okay, let t equals self.t just for readability, and then we say t sinus and amplitude to be defined. Let's say 100. As I size plus 100. Actually, let's do... I don't want to handle the overflow, so let's... Windows keyboard, set your rating at 100. So this is now value, let's say 200. Wait, what was our window size? 640, 320. Let's say 320. So X is now between X is now between 220 and 420, and this was 180 is the center for whatever reason. So we have an X and a Y value. If I look at the block element, I'm just gonna steal this here. I'm not even gonna check bounds. I just want something to move. So this is Y plus Y. And then I basically say buffer O equals self.color. Right? Will this work? As U32, as U32, because we know it will fit. This will just set 1 pixel. I'm not sure if 1 pixel is kind of exciting. Missing T. Oh, missing T. Yeah, true. Oh, come on. Oh, come on. And you see that little green pixel here that jumps in and out. Yeah, 1 green pixel is a little bit less, not enough. And actually what we can do is we make a block out of this. And these are rendered in order, so lists are used. I'm not sure what I want here. Gray. Some kind of gray. It's really hard to see, isn't it? But there's 1 pixel jumping around the screen. Maybe we cheat a bit just for today. So for dx in 0.5, actually, and this needs faster libraries. This is absolutely crappy performance-wise. It's just plus dy plus dx. Come on. I have no idea how I just managed to enter a beta. Oh. This obviously is wrong. What the hell? Oh. Classic. Classic. You see that? Is that visible on stream? That gray thingy there in the middle? Yeah. So what we can do is, okay, I want to have a count, let's say 10. And then we just say for C in self.count and we still have to do the count. Yes, the element still has to do that, but only the element. So I add a count here, which is a use32, probably too much, but I say self.count equals whatever is in count or 1, so the user can omit it. And here I say count defaults to 1, 2. So I'm doing and then obviously I need to do some delta magic here, and I'm just gonna say 0.1 times C as F32. So I expect 10 of these things now with a slight delay. And then also maybe the amplitude, the phase of maybe I just want the sinus to be shifted to the. That's not too bad. I mean, it's showing that it's moving. It's actually, it's showing that the config, I only had to change the element and the config, nothing in between. 100 is probably a bit crazy, but it's a bit static. It could move, but I think it proves the point. So let's build this for ARM. Copy over the config. Copy over. Once you have one bad entry in your history, copy over the binary and let's see what happens. So the config, we see green block, red block, white block, Lisaju, and switch to it, and it's slow as hell because our code is so bad. But it also works as an overlay, and that's where we want to go at, right? So, but I mean, there's one trick we can do to make it much faster instantly. So let's do a release build. Let's do a release build. Actually, while we wait for that, I'm gonna. I want to have a scaling factor in all these values, but I'm not sure how to do that. Okay, we compiled the release version. Obviously, we have to copy over the release version now. And if we run the release version now, it's much, much, much faster. And that's on the Raspberry Pi, and we can key that in. Obviously, the keyer has the wrong colors now, but basically this could be used for nice stream overlay based purely on external hardware. And that's what we want to get to, right? That's what we want to get to. I really want this full screen. I mean, I could do this, make this full screen. Can I? No, we're cheating with the config, so none of the parameters here are actually used. The position is not used. The position is not used, the width is not used, the height is not used. I mean, we could just so this is the width, right? Self.width as f32. This is the height. Self.height as f32. And this is self.x. And this is self.y, correct? Come on. Sorry for speeding up, I just want to wrap this up. And now the position and width of the config should be used. Yeah, that's the wrong one. Attempt to multiply with overflow. Okay, true. True? Wait, what? No? Where are we? Oh, this could be an overflow. Okay, so the point is here we use a saturating at, and that then becomes negative. We actually need to clamp. So if x smaller 0 or x plus 5 larger self.width, we just bail out. And the same for, I'm not sure what I messed up to actually get the overflow. But this should not overflow anymore. Yeah, okay. And this? Why? Attempt to add with overflow in line 38. Oh. That's better. I mean, checking for overflow by creating an overflow is not the smartest idea. And the underflow, technically, we don't even have to check, so why is it in the upper left corner? What did I... Oh, the position is 0, 0. Yeah, maybe we want the position to be the center. That's why it was underflowing. And I messed that up. Wait, what? It's time to stop. I'm over my limit. Hey, Mr. Halsey, I haven't seen you in a while. How's it going? So all these values kind of look okay-ish to me. Right? All these should end up in pixels. I mean, maybe we should do the... What the... actual out of bounds check here. But still, that's okay. I broke it. I'm sorry. I'm not sure entirely because this should result in a pixel on the screen. I mean, and we even get 5 of these roughly in this area, so this should be even more. I mean, this is definitely on screen. So, is it rejected? It's rejecting all of these, so... Okay, probably... I kind of want the underflow here. Yeah, and see, this would have just worked. Oh. We had this before, right? Yeah. So we were checking with our bounds instead of the frame bounds, and if we check against our bounds, bad things will happen. So the nice thing now is, if I copy this little yeah, let's call this Lizza1. Lizza1. Let's use this. And let's just say we have one that's slightly larger, and slightly darker. I'm not sure what's visible on stream, so we're starting to have fun with this. I mean, what we really offset is, I don't know, 1. So we have an offset f32. We say self.offset equals config offset or 0.0 as f32. We should handle floats. But not today. This is dummy code anyway, and then where the hell am I? Let's see. Oh, yeah. Talking about F32 and typing U32 is maybe an offset of 1 is not big enough. Let's have an offset of 10. Oh, 10 is probably too much, but you see? Okay, sorry. Having too much fun. Let's try release. So I'll be working on this Tuesdays and Thursdays until it does what I want it to do, if my day job permits. So if you want to keep following along, don't forget to follow. Oh, cute. I edited the same values in both of them. I changed widths in both of them. I wanted height in one and widths in the other. I mean, now we're just fooling around, but this is nice, and I want to do the Raspberry version, the release version, because it will be hell slow on. Copy the release version, copy the new config file, and run it on the Pi. Want to see it? Ooh, fast. So, but what I really want to do is, so let's make the green block green. Let's make it actually full screen, and make the Lizzie's width what's half 1980? It's 990, right? 540. Probably messed these up, but code should be safe anyway. Let's see. Let's just see what happens. It doesn't crash. Did I break the config? Yes, I did. We need feedback on broken configs, but oh, nope, I didn't want white, I wanted green for the green. So, what is this getting in the ballpark? So let's go back to my stream, enable the keyer, and it's too fast. I still think we might have, looking at this, either the keyer is broken or maybe the output of the Raspberry is just bad. But I mean, in the end, that's not what we want. We want overlays, right? We want our stream box and our follows and our title for the stream and stuff like that. And that should be easy to do. But we can do full screen real-time animation overlay over the stream, which is good to know. And actually, I don't want that animated. I'm a bit worried about the fuzzy edges. Maybe we need to double the pixels. Maybe it doesn't like this half pixel precision. Maybe that, or maybe it's just a bad HDMI cable. I mean, okay, this is keying itself, which is not gonna do, but I like this. And none of this is fast, so none of this is optimized for speed. It's all just brute force chaos. So But I kind of like this. I mean, obviously then we want stuff like display images, display animated images, display text, display time, display, I don't know, the weather? Well, if it's gonna be a smart mirror, it's gonna display the weather, right? So I had a long day, it was a good stream. I'll say I'll see you on Tuesday, and thanks for being here. Bye bye.